So we would like to find equation of the tangent plane and the normal line at the point or this given point on this surface. So first let's just go ahead and graph the surface using MATLAB. So in this situation, you know that we use the implicit 3D graphing feature. And here I just took the window as the window that includes the point that we are given. And let's see. So here is a graph of the surface, and our point of interest or the contact lies on this upper part of the surface here. Okay, so let's just go ahead and find the equation of the tangent plane and the normal line. So first we form a function of three variables. Then we know that the three partial derivatives give us the components of the normal vector at a point x, y, z. So if we substitute these values of x, y, and z in here, what we are going to get is that the normal vector is you can see y and z, they multiply to 1. So this gives us 1, and we get the other two components of the normal vector just by utilizing these coordinates and their substitutions in here. So our desired plane is the plane passing through this point and normal to this vector. So what that will be, the first normal component is 1. So that's so we will write a 1, I'm just formally writing it, and then x minus 2, then plus the second component, that is 2 ln 2, and we use the coordinates, and then that gives us equation of the, let's remove this, equation of the normal plane at this point as this, okay? And here, let me just get my extra plus sign off here. So what I'm going to do now is that I'm just going to put this in the implicit graphing feature for MATLAB. We can graph it in Scientific Notebook, but for me that will work a little better. So I just typed in this script already, and then I'm just inserting it. So if I say Control Enter, I should be able to see the plane. So let's see that our plane is correct. Yes, it is. Okay, so now we are going to write our normal line, that is a line through this point and parallel to this vector, or in other words, line through this point that was given and is parallel to this vector. So an equation will be x will be 1, or actually 2, the x coordinate is 2, and plus how much? 1 times t, that is just t. And same way we can write the y and z coordinates as functions of t. And now we are going to graph it in MATLAB. So now we are going to bring in a function of t, or a parametric function of t. So we should not forget to introduce this syms t here. Okay, and now I wrote the command already out for you. So we should see the normal line. And actually, let's take that to a bigger window. And all right, so here we are. And then you can do this. Remember, we have gone over like how to rotate these things and everything. So anyways, so here is our graph as desired. All right. And I shall post the commands for you in the description of the video.